Hello students, welcome all of you. In this video, I Abhay Kumar going to solve NCERT textbook 1 problems 4.20 and 4.21 based on the motion of a particle in a plane. Of chapter 4, motion in a plane for class 11 physics in video number 21 of this chapter. इस वीडियो में मोशन ऑफ ए पार्टिकल इन ए प्लेन पर बेस्ड एनसीईआरटी टेक्स्ट बुक 1 का प्रॉब्लम्स 4.20 एंड 4.21 का सॉल्यूशंस किया जाएगा। क्लास 11 फिजिक्स का चैप्टर 4 मोशन इन ए प्लेन का। फर्स्ट ऑफ ऑल प्रॉब्लम नंबर 4.20. The position of a particle is given by r vector equals to 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap meter, where t is, that is time small t, is in seconds, and position vector a small r vector to be in meters. Part A, find the velocity v vector and acceleration a small a vector of the particle, and in part B, what is the magnitude and direction of the velocity of the particle at time t is equal to 2.0 second. किसी पार्टिकल का पोजीशन को एक्स वाई जेड कोऑर्डिनेट एक्सिस का पॉइंट ऑफ इंटरसेक्शन दैट इज ऑरिजिन ओ के रेस्पेक्ट में एक्सप्रेस किया गया है पोजीशन वेक्टर को। आर वेक्टर इज इक्वल टू 3.0 टी आई कैप माइनस 2.0 टी स्क्वायर जे कैप प्लस 4.0 के कैप मीटर। यहाँ आई कैप जे कैप एंड के कैप यूनिट वेक्टर्स हैं एक्स वाई एंड जेड कोऑर्डिनेट एक्सिस के लॉन्ग। तो चूंकि पोजीशन पार्टिकल का पोजीशन वेक्टर को एक्सप्रेस किया गया है 3 कंपोनेंट्स, मतलब एक्स वाई एंड जेड कंपोनेंट्स तीनों प्रेजेंट है, इसलिए पार्टिकल का मोशन एक्स वाई जेड प्लेन में है इस प्रॉब्लम में। दैट इज मोशन ऑफ द पार्टिकल इज इन स्पेस। तो पार्ट ए में पार्टिकल का वेलोसिटी एंड एक्सेलरेशन को कैलकुलेट करना है, को मालूम करना है, एंड पार्ट बी में पार्टिकल का मैग्नीट्यूड ऑफ वेलोसिटी एंड डायरेक्शन को t इक्वल टू 2.0 सेकेंड दैट इज 2 सेकेंड पर कैलकुलेट करना है। नाउ वी हैव टू सॉल्व इट। द पोजीशन वेक्टर ऑफ द पार्टिकल इज गिवन बाय a small r vector equals to 3t I cap minus 2t square j cap plus 4k cap meter. Suppose it is equation number 1. In part A, first of all we have to find the velocity of the particle. Velocity of the particle can be obtained by differentiating equation 1 both sides with respect to time. In LHS it is position vector r vector, so after differentiating LHS with time it is dr by dt. dr vector by dt is velocity, so differentiating equation 1 both sides with respect to time, we have dr vector upon dt and it is velocity of the particle v vector. And in RHS first term is 3.0 t I cap, so 3 is constant, so it is 3 into d by dt of t, and d by dt of t is 1, so it is 3 into 1 I cap minus 2 is also constant, so it is 2 into d by dt of t square, and differentiation of t square is 2t, so it is 2 into 2 multiplied by 2 is constant, and differentiation of t square with respect to time is 2t j cap, and 4 is constant, so differentiation of 4 that is d by dt of 4 is 0, so third term is differentiation of third term that is 4 k cap is due to constant term 4, differentiation of third term is 0, so we have only 2 terms in RHS, so it is 3 I cap minus 4 2 into 2 that is 4 t j cap, and unit of velocity is meter per second. Suppose say it is equation number 2. So we have calculated velocity of the particle v is equal to, after differentiating position vector r vector of the particle with respect to time, dr by dt is equal to v, and in RHS it is 3I cap minus 40 j cap meter per second. Now for acceleration of the particle, we have to differentiate velocity of the particle with respect to time. अब पार्टिकल का एक्सेलरेशन को मालूम करने के लिए वेलोसिटी को टाइम के रिस्पेक्ट में डिफरेंशिएट करना होगा. सो डिफरेंशिएटिंग इक्वेशन 2 इन विच वेलोसिटी इज गिवन v वेक्टर इज इक्वल टू 3I cap minus 4t j cap with respect to time. So we have acceleration of the particle. After differentiating equation 2 with respect to time, we have dv upon dt, rate of change of velocity, and it gives acceleration a vector. Acceleration is denoted by the symbol small a vector, equals to in RHS, that is d by dt of 3I cap. 3 is constant, so d by dt 3 into that is differentiation of 3, that is only 3I. So differentiation of d by dt of 3 is equal to 0. So first term is 0. Differentiation of first term 3I cap is 0. So it is 0 minus second term is 4t j cap. So 4 is constant. So it is 4 multiplied by d of dt, d by dt of t, time का differentiation time के respect में, d by dt of t is 1. So it is minus 4. 4 के पहले माइनस है, minus 4 into d by dt of t, that is 1, into j cap, that is minus 4 j cap, and unit of acceleration is meter per second square, and say it is equation number 3. So acceleration of the particle we have obtained after differentiating equation 2, that is velocity with respect to time, dv by dt is equal to a vector is equal to minus 4 j cap meter per second square. Now in part B, we have to find the magnitude and direction of the velocity of the particle at time t is equal to 2 seconds. So putting to find the velocity of the particle at time t is equal to 2 seconds, we have to put t is equal to 2 in RHS of equation 2. So equation 2 is v vector is equal to 3I minus 4t j cap meter per second. So putting t is equal to small t is equal to 2 seconds in equation number 2, we get velocity of the particle at time t is equal to 2 seconds. So it is v is equal to v vector, velocity of the particle at time 2 seconds is 3I cap minus 4 into value of t is 2 seconds. So 3I cap minus 4 into 2. In place of t, we have written 2 and j cap 3I minus 4 into 2 j cap, and it is unit of velocity is meter per second, that is 3I cap minus 8 j cap meter per second, and say it is equation number 4. So velocity of the particle at time t is equal to 2 seconds we have obtained is v vector is equal to velocity of the particle at time 2 seconds, t is equal to 2 seconds is 3I minus 8 j cap meter per second. Now magnitude of velocity is given by mod of v vector equals to under root vx square, x component of velocity का square plus y component of velocity का square, root under vx square plus v.y square, that is vx is coefficient of I cap, that is 3, x component of velocity is plus 3, so it is 3 square plus y component of velocity is minus 8, so it is minus 8 square, that is 3 square is 9 plus minus 8 square is 64, so it is root under 64 plus 9, root under 73, and square root of 73 we can obtain 8.54 meter per second. That is magnitude of velocity of the particle is 8.54 meter per second. This is the answer of part B. That is magnitude of velocity of the particle at time t is equal to 2 seconds is mod of v vector is equal to root under vx square plus vy square is equal to root under 3 square plus minus 8 square, that is root under 9 plus 64 is equal to root under 73 is equal to square root of 73 8.54 meter per second. Now direction of velocity we can obtain tan theta. If theta, let theta be the angle which the velocity makes with x axis. सपोज किया जाए कि वेलोसिटी का जो डायरेक्शन v वेक्टर पार्टिकल का वेलोसिटी है वह एक्स एक्सिस से थीटा एंगल फॉर्म करता है, तो tan थीटा इज इक्वल टू for direction of velocity we have V.V.I upon Vx, y component upon x component, y component is minus 8 and x component is 3, so tan theta is equal to minus 8 upon 3, that is, or tan theta is equal to minus 2.666, that is 2.67, so tan theta that is minus 8 by 3, or we can write tan theta is equal to minus 2.67, therefore theta is equal to tan inverse minus 2.67, and we can obtain theta is equal to minus 70 degree with x axis. Tan inverse minus 2.67 is minus 70 degree with x axis, so theta is equal to minus 70 degree with x axis, and this is the direction of velocity of the particle with x axis. This is the answer of this problem. Magnitude of velocity of the particle at time t is equal to 2 seconds is 8.54 meter per second, and direction of velocity of the particle at time t is equal to 2 seconds is theta is equal to tan inverse minus 8 by 3, that is tan inverse minus 2.67, that is minus 70 degree. Theta is equal to minus 70 degree with x axis. Now we have to solve problem number 4.21 NCERT text problem. The problem is a particle starts from the origin at t equal to 0 second with a velocity of 10 j cap meter per second and moves in xy plane with a constant acceleration of 8.0 I cap plus 2.0 j cap meter per second square. Part A, at what time is the x coordinate of the particle 16 meter, and what is the y coordinate of the particle at that time. जिस टाइम पर s कोऑर्डिनेट पार्टिकल का 16 मीटर दिया है तो उस टाइम पर y कोऑर्डिनेट कितना होगा पार्ट ए में मालूम करना है, उस टाइम को मालूम करना है जिस पर कि पार्टिकल का x कोऑर्डिनेट दैट इज डिस्टेंस कवर्ड बाय द पार्टिकल अलोंग x एक्सिस 16 मीटर है। साथ ही उस टाइम पर जिस टाइम को मालूम करना है उस टाइम पर y कोऑर्डिनेट कितना होगा दैट इज डिस्टेंस कवर्ड बाय द पार्टिकल अलोंग y एक्सिस, उसे भी कैलकुलेट करना है। एंड पार्ट बी में व्हाट इज द स्पीड ऑफ द पार्टिकल एट दैट टाइम, उस टाइम पर जिस टाइम पर x कोऑर्डिनेट 16 मीटर है तो उस टाइम पर पार्टिकल का वेलोसिटी का मैग्नीट्यूड दैट इज स्पीड, मैग्नीट्यूड ऑफ वेलोसिटी इज स्पीड, तो स्पीड कितना होगा वह मालूम करना है। मतलब उस टाइम पर जिस पर पार्टिकल का x कोऑर्डिनेट 16 मीटर है तो उस टाइम पर पार्टिकल का स्पीड दैट इज मैग्नीट्यूड ऑफ वेलोसिटी कैलकुलेट करना है पार्ट बी में। जबकि पार्टिकल अपना मोशन स्टार्ट करता है ऑरिजिन से, दैट इज ऑरिजिन इज द रेफरेंस पॉइंट, दैट इज द पॉइंट ऑफ इंटरसेक्शन ऑफ एक्स वाई कोऑर्डिनेट एक्सिस, बिकॉज मोशन ऑफ द पार्टिकल starts motion, that is the particle starts its motion from the origin, that is the reference point of the point of intersection of two coordinate axes, that is O, along y axis. Initial velocity, initial direction of velocity of the particle is along y axis, so u vector is equal to 10 j cap. It is given 10 j cap. Initial velocity of the particle is 10 j cap, u vector is equal to 10 j cap. That means the particle is moving along, j cap is the unit vector along y axis, so 10 j cap represents the particle is initially the particle is moving along y axis, so u is equal to 10 j cap, and then motion of the particle is in xy plane, so position vector of the particle at time t can be represented by xi cap plus yj cap. सपोज किया जाए एक्स वाई प्लेन में पॉइंट पी है, यहाँ पर पार्टिकल का पोजीशन है, लोकेशन है टी टाइम पर, पी पॉइंट का कोऑर्डिनेट एक्स वाई है, तो पी पॉइंट से परपेंडिकुलर ड्रॉ किया जाए एक्स एक्सिस पर तो पी एन जो है वाई कोऑर्डिनेट होगा, परपेंडिकुलर का फुट यहाँ मीट करेगा तो पी पॉइंट से एन का जो वर्टिकल डिस्टेंस होगा वह वाई कोऑर्डिनेट होगा जिसे कैलकुलेट करना है। जबकि ऑरिजिन से परपेंडिकुलर का फीट, मतलब पी पॉइंट से परपेंडिकुलर ड्रॉ करने पर परपेंडिकुलर का फिट एन पॉइंट पर है, तो ओ एन जो डिस्टेंस होगा एक्स एक्सिस के लॉन्ग टी टाइम पर पार्टिकल का एक्स कोऑर्डिनेट जो कि दिया है एक्स इक्वल टू 16 मीटर, लेकिन वह टाइम मालूम करना है। सो इट इज गिवन u is equal to initial velocity of the particle, u vector is equal to 10 j cap, and it is meter per second, unit of SI unit of velocity, and acceleration of the particle is also given, a vector equals to 8.0, that is 8 I cap plus 2.0 j cap, that is 8 I cap plus 2 j cap, and unit is meter per second square. This is the acceleration of the particle. And position vector of the particle we can express it as r vector is equal to x I cap plus y j cap. Position vector of the particle in xy plane, which is represented by OP vector in this figure. So OP represents the position vector, that is r vector of the particle at time t, and it can be expressed as r vector, that is position vector of the particle at time t. R vector is equal to x I cap plus y j cap, and it is in meter. SI unit of position or displacement is meter. So r vector is equal to x I cap plus y j cap meter. Now in part A, first of all write the equation of motion of the particle in xy plane, which is given by r vector is equal to ut plus half at square, similar to the equation of motion, one of the equations of motion in one dimensional accelerated motion. S is equal to ut plus half at square. S is the distance covered by the particle along a straight line, say along x axis, the displacement of the particle or distance covered by the particle after time t s. So in place of s we can write displacement or position vector of the particle in xy plane as r vector equals to u vector t plus half a vector into t square. This is, suppose it is equation number 1, and this is one of the equations of motion of the particle in a plane r vector, that is position vector of the r vector is equal to u vector into t plus half a vector into t square. A is the acceleration of the particle, u is the initial velocity of the particle, and r is the position vector of the particle at time t. So this equation represents the position of the particle at time t. R vector is equal to u vector t plus half a vector t square. In place of r vector we can write position vector of the particle in xy plane as x I cap plus y j cap. So in place of r cap we can write x I cap plus y j cap equals to, u vector is given, initial velocity of the particle along y axis is 10 j cap. So in place of u we can write 10 j cap multiplied by t is the time, plus half a vector is given, also given 8 I cap plus 2 j cap under bracket, out of bracket it is t square. So 1/2 under bracket multiplied by under bracket, value of acceleration is 8 I cap plus 2 j cap given, bracket closed, and out of bracket it is t square, so multiplied by t square. 2 से हम कैंसिल करा सकते हैं, अंदर ब्रैकेट के अंदर 8 को कैंसिल करा सकते हैं, 8 I कैप का टर्म, 8 I फर्स्ट टर्म 8 I के 8 को 2 से कैंसिल कराने पर 4 हो जाएगा, और फिर सेकेंड टर्म 2 j कैप में भी 2 को कैंसिल करा सकते हैं 2 से, तो j कैप ओनली बचेगा. So inside the bracket now it is, after cancellation inside the bracket it is 4 I cap plus j cap in place of 8 I cap plus 2 j cap after cancellation by 2 in the denominator. So we have x I cap plus y j cap equals to 10 j cap into t, we can write it as 10t into j cap plus 4 into t square I cap, अब ब्रैकेट हटा दिया जाए तो 4 I cap into t square, that is 4t square I cap plus j into t square, j cap को भी t square से मल्टीप्लाई करेंगे, तो j into t square, that is t square multiplied by j. Now it is, we can write it as it is 4t 4t square I cap plus 10t j cap प्लस टी स्क्वायर जे कैप, दोनों में इन बोथ टर्म्स दोनों में जे कैप प्रेजेंट है यूनिट वेक्टर along y axis. So in both terms, that is in 10t j cap and t square j cap is present. So j cap will be common. So we can write 10t plus t square bracket closed, and out of the bracket j cap is common. So we have xi plus yj cap equals to 4t square I cap plus 10t under bracket 10t plus t square j cap. Now equating the coefficients of coefficients of I cap and j cap in both sides of this equation. Suppose it is equation number 2. So equating the coefficients of I cap and j cap in both sides of equation 2. We have in LHS coefficient of I cap is x meter, and in RHS coefficient of I cap is 4t square. So x will be equal to 4t square after equating the coefficients of I cap in both sides of equation 2. So it is x is equal to 4t square, and suppose it is equation number 3, and now equating the coefficient of j cap in both sides of equation 2. So coefficient of j cap in LHS is y cap, y, j cap is unit vector, y is the y coordinate of the particle after time t. So coefficient of j cap in LHS is y, and in RHS coefficient of j cap is 10t plus t square. So equating the coefficients of j cap in both sides of equation 2, we have y equals to 10t plus t square. Now x coordinate of the particle at time t is given, which is 16 meter in the problem. x coordinate particle का t टाइम पर दिया है, तो टाइम वह टाइम t कैलकुलेट करना है. तो x इक्वल टू 16, पुटिंग x बराबर 16 मीटर, दैट इज since x इक्वल टू 40 स्क्वायर, therefore 16 इक्वल टू 40 स्क्वायर और t स्क्वायर इक्वल टू 16 by 4, that is 4, therefore that is t square is equal to 4, therefore t is equal to root under 4 is equal to 2 second. Answer. So when the time t is equal to 2 second, s coordinate of the particle will be 16 meter, which is given in the problem. S coordinate of the particle is given 16 meter in the problem. Then time is equal to, time we have calculated, t is equal to 2 second. Now we have also calculate y coordinate of the particle at that time, that is at time t equal to 2 second, we have to calculate the y coordinate of the particle. So putting t equal to 2 second in this equation, y is equal to 10t plus t square, y coordinate के लिए भी हमारा equation है, if you say it is equation number 4. So putting t square putting t is equal to 2 second in RHS of equation 4, then we obtain the y coordinate of the particle at time t is equal to 2 second. So y is equal to y coordinate of the particle at time t is equal to 2 second is y is equal to 10 multiplied by 2 plus 2 square, that is 10 into 2 is 20, plus 2 square is 4, that is 20 plus 4 बराबर है 24 meter. Answer. So y coordinate of the particle after time t is equal to 2 second is 24 meter, and time is equal to 2 second when x coordinate of the particle is 16 meter, which is given in the problem. So we have solved part A of this problem. We have solved part A of this problem. Now we have to solve part B of this problem. What is the speed of the particle at that time? That is at time t is equal to 2 second. We have to obtain the magnitude of velocity. Magnitude of velocity. Magnitude of velocity, that is the speed of the particle. Mod of v vector. So first of all, we have to obtain velocity of the particle at time t is equal to 2 seconds. So to obtain velocity of the particle at time t, differentiating equation 1, that is equation of motion, we have used equation of motion of the particle in xy plane, which is r vector is equal to ut vector, u vector into t, u vector into t plus half a vector t square. Acceleration is a vector quantity whereas time is a scalar quantity. So for the solution of part B, to obtain the velocity of the particle at time t, differentiating equation 1 both sides with respect to time. So we have dr upon dt. In LHS it is position vector, rate of change of position vector with time. Dr by dt is velocity of the particle. V vector is the velocity of the particle after time at time t equal to ut. U into u is constant, u into d by dt of t is 1. So time का differentiation time के respect में d by dt of t is equal to 1 and u is constant, initial velocity is constant. So it is in first term it is after differentiating first term with respect to time we have only u vector plus 1 by 2. Second term is 1 by 2. A vector is also constant. A vector is also constant. 1 by 2 is also constant. Then differentiation of t square with respect to t is d by dt of t square is 2t. So it is 2t. D by dt of t square is 2t. 2 and 2 will cancel out. So it is v vector is equal to velocity of the particle at time t. After time t is u vector plus a vector into t. Now putting the values of u vector which is given in the problem, initial velocity and acceleration is also given, and taking time t is equal to 2 seconds because we have to find velocity of the particle at t is equal to 2 seconds. हम लोगों को t is equal to 2 सेकंड पर पार्टिकल का वेलोसिटी मालूम करना है. तब इक्वेशन जो हमें ऑब्टेन हुआ वेलोसिटी के लिए v is equal to we have obtained v is equal to u plus at. तो इसमें u के जगह पुट करेंगे 10 j कैप एंड a के जगह 8i plus 2 j कैप एंड टाइम t के जगह 2 सेकंड. तो 2 सेकंड पर वेलोसिटी हमें मालूम हो जाएगा. इक्वेशन आ गया वेलोसिटी के लिए आफ्टर टाइम t सेकंड v is equal to u vector plus a vector into t after differentiating equation 1, that is equation of motion in xy plane. R vector is equal to u vector t plus half a t square. This is equation number 1. We have already used in part A. This equation was already used in part A. So we have differentiated this equation both sides with respect to time. So dr by dt, rate of change of in LHS, dr by dt is velocity, and velocity of the particle in xy plane after time t. So v is equal to u plus at. Now putting u is equal to 10 j cap plus a vector is equal to 8 I cap plus 2 j cap multiplied by time t is equal to 2 seconds. So putting t is equal to 2 seconds, we have velocity of the particle at time t is equal to 2 seconds. So we have v is equal to v vector, that is velocity of the particle after time 2 seconds. Now we can obtain it. V is equal to velocity of the particle at, this is velocity of the particle at time t is equal to 2 seconds. Velocity of the particle at t is equal to 2 seconds. V vector is equal to u vector is 10 j cap plus acceleration का value a vector is 8 I plus 2 j cap multiplied by t is 2 seconds. So it is 8 into 2, that is 16 I plus 2 j into 2, that is 4 j. So we have 10 j plus ब्रैकेट हटाने के बाद 8 I को मल्टीप्लाई करेंगे 2 से तो 16 I कैप प्लस 2 j को मल्टीप्लाई करेंगे 2 से तो इट इज 4 j कैप. Now it is 10 j cap. Now it is 10 j cap plus 4 j cap, that is 14 j cap. So it is 16 I cap plus 14 j cap, which is the velocity of, which is v vector, that is velocity of the particle at time t is equal to 2 seconds. Is v vector is equal to 10 j plus 16 I plus 4 j, and it is 16 I plus 10 j plus 4 j is 14 j, and let it is equation number now 5. Total equation 5. So velocity of the particle at time t is equal to 2 seconds is 16 I cap plus 14 j cap. Now we have to find the magnitude of velocity, that is we have to calculate the speed of the particle at time t is equal to 2 seconds. So magnitude of velocity is the speed. We know that magnitude of velocity is a speed. So a speed of the particle at time t is equal to 2 seconds is magnitude of velocity. Therefore, the speed of the particle at t is equal to 2 seconds is given by mod of V vector is V, mod of V vector, mod of magnitude of velocity is speed, mod of V vector is equal to V is equal to root under Vx square plus Vy square. X component of velocity is coefficient of I cap, it is 16 square, X component of velocity at 2 seconds, and Y component of velocity at 2 seconds is coefficient of J cap, which is 14. So mod of V vector, that is the speed of the particle at time t is equal to 2 seconds, is mod of V vector is equal to speed V is equal to root under 16 square plus 14 square. That is we have 16 square, which is 256. That is root under 256 plus 14 into 14 square is 196, and it is now adding both. It is 6 plus 6 12, remainder 1, 9 plus 5 14 plus 1 15, remainder 1, 2 plus 1 3 plus 1, root under 552. It is root under 552, which is the square root of 552 is approximately 21.26 meter per second. So magnitude of velocity is 21.26 meter per second. This is the speed of the particle at time t is equal to 2 seconds. That is mod of V vector is the speed. Velocity is V vector is equal to 16I plus I cap plus 14J cap. So mod of, this is the velocity of the particle. This is the velocity of the particle moving in xy plane at time t is equal to 2 seconds each. V vector is equal to 16I cap plus 14J cap. So speed of the particle at t is equal to 2 seconds is mod of velocity, magnitude of velocity, mod of V vector is equal to V is equal to root under 16 square, x component of velocity square plus y component of velocity square, that is 16 square plus 14 square is equal to root under 16 square is 256 plus 14 square is 196, that is root under 452, that is 452, and the square root of 452 is 21.26 meter per second. This is V, that is a speed of the particle at time t is equal to 2 seconds. Now this video is completed. Thanks all of you for watching my YouTube channel Physics Quantum Classes.